This is the star Sirius, and you can see how fast the orb velocity is counterclockwise around the center of the nucleus. The star itself is a orb cluster nucleus. There's a large orb cluster which I've shown in many previous videos that surrounds this star, and Sirius, the star, is the energy center for that large or enormous orb cluster. And you can see how fast its revolutions are counterclockwise around the nucleus. Even the nucleus itself, the center of the nucleus itself, is spinning at a very high velocity, and that's why the star is a high energy star, and it's bright white. At times it'll change color. Okay, when it's bright white, it's the fastest. When it's a different color, like red, it's slower. When it's blue, it's even slower. But in any of those colors, it's still a high energy star, and the spin of the orbs around the nucleus is supersonic or hypersonic, I should say, especially at the center of the nucleus, because they're going around a smaller circumference or sphere. That big orb that's in the center of the nucleus there, that's spinning too, and that's causing all the other orbs to spin even faster. That determines the rate of the spin. Okay, that's not a hole, that's a big orb in the center. There's rings around it with smaller orbs. There's many rings. There's a mixture of large and small orbs inside the nucleus itself. There are rings on the outside of the primary nucleus, or the center. The whole thing is a hexahedron. You can see it now. But when the orbs revolve so fast, or at such a high velocity, then it looks like it's a circle or a sphere, but it's a hexahedron that the outer rings of the that spin around the nucleus, they're close to the edge. They spin around different shape, a hexahedron shape. Okay, the nucleus center, they spin around the big orb, and then they form the hexahedron. And there are many rings involved in this whole thing. So the outer orbs there, they spin around the hexahedron, and their velocity around that hexahedron, which you can see right now, on and off. Okay, their velocity makes the star appear to be round. Okay, but that's just an illusion, because the star is in the form of a hexahedron. Okay, it's the revolutions around it at a hypervelocity that create a sphere. I could see plasma and everything. Most of it is just all plasma, because of the intensity of the spin, or the revolutions around the nucleus, and the velocity of the orbs. Orbs also spin on their axes, on their own axes, so there's a lot of spinning going on. Orbs are also charged positively and negatively. They carry both charges, so they have to align themselves in order not to interfere with any other orb's charge. So all of these alignments, each orb, and then as a collective or as a cluster like that, and then aligning this whole nucleus with the outer cluster, which is not visible at the moment because the star is so bright. All of that takes a lot of planning, and all of this takes milliseconds in terms of time, according to us. But this is just sort of like spatial displacement or placement and velocity, because we just invented time to make things easier to understand. I'm going to try and see if I can yeah. There. Has an object on each side. That's a good one. I have the capability on the video to get any closer. Only when I take pictures, then I can get closer. But anyway, if these come out clear, they can always be magnified because the lens is good and so is the camera. I thought I saw things, maybe. Yeah, there's an extra one. Not at the right angle, but it's convenient. Yeah, there's three. For sure. There's two on the left, one on the right. Be more. Sometimes they're hard to see. Sometimes they double up. There's like two where it only looks like one from here. Sometimes there's more than one. bunch up together. Okay, my hands are getting cold because I can't wear gloves, so I'm going to switch just the camera.